Hi and welcome to Math for All. In today's lesson, we're going to be looking at how we can solve systems of equations by graphing. And so math builds on the concepts that you have learned in the past. And today's lesson, it's the first lesson at a grade 10 level. And it deals with a lot of the things that you have been doing so far or have done in grade 9. Today we're going to be looking at a couple of linear equations. And we're going to look at what it actually means to be able to solve those linear systems of equations by graphing. Whenever we have two linear equations and we're being asked to solve a system by graphing, what the question is asking us really is that it's asking us to find a point where these two lines cross. As long as two lines have different slopes, lines will always find a point or a place where they will intersect. Just a little bit of a reminder from what a linear equation is. This is a slope-intercept form, a linear equation in a slope-intercept form. It is written as y equals mx plus b. M represents the slope and b represents the y-intercept. Y-intercept is a place where the line can actually cross somewhere along the y-axis. So a line can travel either in an upward direction or in a downward direction. Sometimes it can be vertical or horizontal. In this case, we're going to keep things simple. We'll talk about lines that travel up, and these would have positive slopes, and lines that can travel downward that would have a negative slope. A graph is always read from left to right, kind of the same way we read in English. And so we read from left to right. And so if we have a line going down, we're actually looking at a downward slope. A line goes up, this is an upward slope. The greater the number, the steeper the slope. And so if you increase the number, the line would actually become more and more vertical. Similarly with a negative slope, the greater the number, the steeper the slope, but in a more negative direction. Let's take a look and see how we can graph these two equations. Okay, so just to kind of recap what you used to do in grade 9. In order to start graphing, we always begin by finding a reference point. And the reference point comes from looking at these free numbers, which represent our y-intercepts. Our first equation, the y-intercept is 3. And so we're going to put a point. It tells us that when x is 0, 4 times 0 is 0. So y would be equal to 3. So we can put a point right here. And then from this point, we're going to begin our count. We're going to look at this point right here, which represents our slope. And the slope is usually represented as rise over run. Sometimes it's difficult to understand what does that mean to have a rise and what does it mean to have a run. Well, the rise tells us how many increments do we go up by before we actually go across. Here we have the number 4. 4 is a whole number. So 4 can also be written down as a fraction. So we can write it as 4 over 1. It's the exact same thing. 4 over 1 tells us that we rise or we go up from this point by 4 points. 1, 2, 3, 4. And then we move across, or we run across, horizontally across, by a single point. So in this case, 1, 2, 3, 4, and then we go always towards the right, and we put a point right there. We can do it one more time. We can place our point, and then we can connect these points using a ruler. Okay, and here we have it. Don't you just wish your answer sometimes would just appear on the page? Okay, for this equation, we have a negative slope, and then we have this number. It says minus 2. What does that mean? That's our starting point. So we go down to negative 2, which is our y-intercept. Once again, the y-intercept tells us that when x is 0, what is that value of y? So when x is 0, y equals to -2. That's where this point comes from. Next, the slope is negative, but there's no number. Well, guess what? There is a number. It's an invisible 1. The 1 isn't usually written down. We just assume that if it's an x, we have 1x. So, in this case, our rise is negative. So in fact, it's a drop. And it's going to be a drop and run. So we're going to drop by 1. And if you were to write 1 as a fraction, it would appear as 1/1. So drop represents a negative number. We're going to drop by 1. And the run is always towards the right. So we'll go down 1 over 1, down 1 over 1, down 1 over 1. Okay, usually 2 or 3 points is enough. And then all we have to do is connect those points to get our line. Let's wait and see for the answer to appear on the page. Okay, so now that we have 2 lines, keep in mind that both lines are infinite, and so we can extend them forever. But the one point we're mostly interested in is that we're trying to solve this system of equations by graphing. So we're trying to find what's the point of intersection of these 2 lines, and the point is right here. That's where our lines cross. And so we're actually going to write our answer in brackets, and we need to remember something. Whenever we write coordinates, our brackets first represent a horizontal shift, or rather a horizontal position of a point, and followed by a vertical position of the point. And so our first point horizontally, it's at -1, and in this case it's also vertically at -1. And this would be our first question. Okay, and now on to our next example. Here we have fractions. And so I actually picked this question on purpose. We're going to try graphing our slopes that are represented as in a fractional form. Don't be scared of fractions. In fact, it's a lot easier to graph something like this than ones that have a whole number. So, for our first question, we have 2 lines, line number 1 and line number 2. We're going to do our first one. What's our starting point? We're going to start with -3. And so -3 is where our y-intercept is. And then we have to use the slope. What does that mean? Again, the slope is represented by rise over run. Okay, what's our rise? The rise is that upper number, so it's number 1, and our run is number 3. Which means once we go down to this level, -3, we go up by 1, and then we go horizontally towards the right by 3 units. Up 1, and then 1, 2, and 3. Point. Up 1, over 1, 2, 3, and point. Okay, so we have 3 points. We can actually connect them and form a line. Let's see if I can do it by hand. Next, for the second question, rather for the second line, we have to recognize the negative. And so it has a negative slope, which means our line is supposed to go down in this direction. This is our starting point, +2. We go to +2, put a point. The slope is a drop of 3, and then we go across by 2. So we drop by 3, and we go across 2 units towards the right. Let's start here. 1, 2, 3, and then 2 units towards the right. 1, 2, 3, 2 units towards the right. We have our points. We can connect them, and we find the most important point, which is the point where the lines cross together. Again, we're going to write our brackets. Our first point inside that bracket represents our horizontal positioning. Horizontally, we are positioned at 2 units from 0, 0. 1, 2. And 1 unit down. So vertically, we go down by 1. Horizontally by 2, vertically down by 1.